Here we're looking at example 3 from our 3.4 set of notes. We're asked to pretty much solve this system of equations. Now, when we're looking at our system, we're trying to use that strategy of trying to get one of the variables to cancel immediately, and if possible, try and get lucky with canceling out multiple variables. When I'm looking at my equations, I notice that my top one, or my red one, has x, y, and z. When I'm looking at our other equations, I'm noticing that our bottom one, we'll just say that he is the blue one, has a coefficient of 4 for the x value. It also has a coefficient of 4 for the z value. And as a result, when I use linear elimination, or I'm sorry, when I use the elimination method, we're going to, we notice that if we multiply this one by like -4, that the x's and the z's would end up dropping out. So what we're going to do is just use our red and blue one. For right now, we're going to ignore the green one and just use those two. So we have x plus y plus z is equal to 6, and our blue one, 4x minus 8y plus 4z is equal to 12. And just like we said, we're going to multiply this top one by -4 on both sides. Such then, when we do that and distribute, we end up with -4x minus 4y minus 4z is equal to 6 times -4 gives us -24. Now when we go ahead and linearly combine these, our x's end up dropping out with one another. We have -12y. Our z's also end up dropping out, and that's equal to, looks like, -12. And from here, it's pretty easy to go ahead and figure out what is our y value. We would just divide -12 on both sides. So then y will come out to be 1. Now that we've found y, we have to go ahead and use our green one, the one that we have not used yet. Because again, if we're trying to figure out some x, y, and z coordinate that works, you have to eventually at some point use all three of these equations, such then that it works for all three of these equations, this point that we're looking for. So now we're going to go ahead and use the green one. So that's 2x minus 3y plus 4z is equal to 3. So that's again the one we must use. And we also though have a choice. We can use our red one or our blue one that we're going to be looking at with our green one. So just looking at things, probably the red one, since all the coefficients are nice and easy, that's probably going to be our preferred one that we're going to take. So we have x plus y plus z is equal to, is it 6 or -6? Just regular 6. Okay. Now, luckily though, we already found out what y was. It came out to be 1. So when we go ahead and substitute that in, we have 2x, again, we don't know what x is yet, minus 3 times 1 plus 4 times z, we don't know what z is either, is equal to 3. For our red one, we can do the exact same thing, throw in 1 in for our y values. We have x plus 1 plus z is equal to 6. Simplifying things further, we'd have 2x minus 3 times 1 is just 3, plus 4z is equal to 3. For our red one, we literally just have x plus 1 plus z is equal to 6. And what we're going to do is just go ahead and combine our numbers onto the other side. So here we would add 3 to both sides. Here we would subtract 1 from both sides. So again, we're really just looking at these equations still individually, have not yet combined them. And for our green one, it looks like it would be, I'll write it up here. For our green one, it looks like he would come out to be 2x plus 4z is equal to 6. Whereas for the red one, should have done this. There we go. For our red one, he's going to come out to be x plus z is equal to 5. Now that we have things in terms of just two variables, we can go ahead and use the elimination method again. So we're going to multiply. You really have a choice here to go whichever variable you want. Maybe we'll just go ahead and try and cancel out the x's. So we'll multiply both sides by -2. And so when we distribute that, it looks like our red equation would come out to be -2x minus 2z is equal to -10. I'll just go ahead and rewrite our green one. That's 2x plus 4z is equal to 6. And now we can go ahead and linearly combine these. We see that our x's drop out, giving us 2z's is equal to, this looks like it comes out to be -4. So then z is pretty manageable to solve for. Just divide both sides by 2. So z now is by himself, which is equal to -2. Now that we have z, we have y, you have some options here. You can really plug them into any one of the originals. You could even plug them into one of these, since like this, for example, this green one is just a derivation of our previous green when we threw in our y value. So there's tons of different options you can go with. I think what I'll do is I'll just show you it being plugged in one of the originals. This x plus y plus z is equal to 6 is probably the easiest one to use, so we'll just use that one. But again, you could use one of these two as well. So x plus y plus z is equal to 12. Nope, that one was the 6th one. And pretty much just throwing in what we do know. Well, right now we currently don't know what our x value is. So he's still x. Plus, we do know our y value. Again, that's 1 that we found earlier. And we also know what our z value is. He's -2. And that's equal to 6. Looks like this will come out to be x. 1 minus 2 is -1, which is equal to 6. Just add 1 to both sides. So x comes out to be 7. So then it looks like our final answer comes out to be 7, comma 1, comma -2. Notice that it is in fact an x, y, z coordinate point though, all three. But again, that is example 3 from our 3.4 set of notes.